Welcome to a lesson with Dr. Powell. Let's take a look at finding the derivative of a composition. This is often called the chain rule. Now let's look at an example. Suppose we have sine of 4x. Let's see what we can do. First of all, we have a function in here, 4x, which is plugged into the function sine x. So we can think, in some sense, that we have sine of something, and we also have 4x. We want to take the derivative of this one and the derivative of this one, and then multiply them together. The derivative of 4x is 4. The derivative of sine is cosine. But now what do we plug in? Into here. We plug into here whatever's going into sine originally, which is 4x. So that's our derivative right there. Let's look at another example. Suppose we have sine of x, and we're raising this to the 5th power. Okay, let's think about what we can do when we take a derivative. We have a function raising to the 5th power, and we have another function, sine x, which goes inside of it. So what we do is we take the derivative of each, and then we multiply them. Just thinking of what goes into this after we take the derivative. The derivative of something to the 5th is 5 something to the 4th. But what's going into this? Well, it's sine x. Next, what's the derivative of sine? It's cosine. And voila, there is the derivative right there. Okay, let's look at another one. What if we have the square root of e to the x plus cosine x? All right, so what we do is we think of two functions. See the square root? So we have square root, and what's going inside of it? E to the x plus cosine x. We take the derivative of square root. Now think of square root as being something to the 1/2 power. So we end up getting 1/2 coming out front, raised to the negative 1/2 power, because you subtract 1 from the exponent. And then here, take the derivative of this. It's e to the x, because the derivative of the x is e to the x, then minus sine x. And these are multiplied. Then what goes in here? Exactly what went in here before. E to the x plus cosine x. And that is the derivative of this. Thanks for watching.